Hi, welcome to this episode of ProofPilot. We are here to talk about first countable spaces. But before that, I want you to hit the subscribe button and like this video. And if there is any question about first countable spaces, I would be happy to answer to them in the comment section. Uh, so to give the definition of what a first countable space is, we need first to introduce neighborhood basis. So by definition, a neighborhood basis for X, which obviously X is a topological space, uh, at a particular point P is a collection of sets, which these sets are open neighborhoods of P. So they have this particular property that if you take any neighborhood of P, then there is a set from your collection. There's a set from your collection that is a subset of your neighborhood. So if we want to summarize what a neighborhood basis is, it would be summarized in these two properties, that each of these sets should contain P, and if you take an arbitrary neighborhood, then there exists some set from your collection that's a subset of your neighborhood. Then there is a specific type neighborhood which satisfy a useful property that may come useful in the future, and they are called nested neighborhood bases. The definition says that this thing right here is just a sequence of sets. Okay, so they are obviously countable. And this is a sequence of sets, and these sets are neighborhoods of P. And we call them a nested neighborhood if they have this property right here, that each the next member of our sequence is a subset of the previous one. So if I want to summarize these two things, the nested neighborhood basis and the neighborhood basis is just like if you take a point in your topological space, the neighborhood basis looks like this. Okay? They are not necessarily a subset of each other. Okay, this is a nested neighborhood. This is the neighborhood basis. But a nested neighborhood would look like this. So if this is your point, then this is a nested neighborhood. Okay, and so on. There are some examples of neighborhood bases. I always say you need examples to understand the concept better. So for this one, if you take all the open balls in Euclidean space, then this would be a neighborhood basis. And this one in particular is actually a nested neighborhood also, but I prefer this. Actually, this is not a nested neighborhood because this is not a sequence, as you can see, and that's an interesting point right there. So this is not a nested neighborhood. Then there is another example, which is this set in the discrete topology. And for example for a nested neighborhood basis is open balls with this radius. As you can see, this you can count this collection of sets, but you cannot count this collection. And now we can get to the definition of what a first countable space is. So the definition says a space is said to be first countable if it has countable neighborhood bases at each point. And this is really trivial if you are thinking about the Euclidean space, but there is a non-example which is really good if you dig this for yourself, and it's the cofinite topology. I really suggest that you go after this. and see what a cofinite topology actually is and why it is not first countable space. So this is the definition of what a first countable space is. It has a countable neighborhood basis at each point. Now we get to the nested neighborhood basis lemma. The lemma says if X is a first countable space, then there exists a nested neighborhood basis at P. So I just want to remind you that a first countable space was a neighborhood basis that was countable, and I just said that the nested neighborhood basis is just a sequence, which means it is countable. So you can see the connection right here, but we just need to build this nested neighborhood basis from our neighborhood basis. So what we are going to do is, let's suppose that they're just finite. Our collection is a finite set. So if they are finite, I want just to satisfy this property that each member of the sequence is subset of the previous one. So to do that, we just say, let's take this collection or set. What was a first countable space? It was a neighborhood basis which was countable. So I can count them. Let's take them as V1, 2, Vn. Okay, if they are finite. So let this be our neighborhood basis. And obviously, I can build my nested neighborhood like this. So if I want to say what the nth member is, I say that un is equal to v1 intersected with v2 to vn. Okay, so this would be the nth member of my nested neighborhood. And as you can see, un plus 1 is a subset of un, because un plus 1 would have to be intersected with vn plus 1. And obviously, this thing right here would be true. And there isn't, and obviously, this is the way we are going to build it for an infinite set. Just we do induction on it, and that's it. I hope you have enjoyed the video. Please comment if there is any question about this content. Thank you for watching.